Hello students, today we will discuss very important name reaction in organic chemistry, that is Kolbe's electrolysis. In the last video we discussed about soda lime decarboxylation and different application. Today same way we will discuss what is Kolbe's electrolysis and what are the application of Kolbe's electrolysis and what are the mechanism of Kolbe's electrolysis we will discuss, and it will be very much helpful for your different competitive examination, JEE and NEET and other different examination. I hope this video will be very much helpful for you. Okay, without wasting your time, let us start. The today's topic is Kolbe's electrolysis reaction. The Kolbe's electrolysis reaction, if you see the main theory of Kolbe's electrolysis, the statement is like this. You can say sodium salt of carboxylic acid when undergo electrolysis produce alkane. With alkane, hydrogen gas, carbon dioxide is formed, and the solution will become alkaline due to formation of sodium hydroxide. This is the first reaction. That again I am repeating, sodium salt of carboxylic acid when undergo electrolysis, alkane is formed and hydrogen gas, carbon dioxide and NOH is formed. Similarly, if you see sodium salt of dicarboxylic acid, if you take dicarboxylic acid, same by electrolysis, we will get alkene or alkyne. We will get alkene or alkyne, and the same product like your first one, hydrogen gas, carbon dioxide and NOH will be formed. So this is the main theory of Kolbe's electrolysis. Salt of carboxylic acid when undergo electrolysis, the product is alkane, alkene or alkyne. So these are the main product. If you see the example, let us take the example is like this. CH3COONA when undergo electrolysis, the product is ethane, carbon dioxide, hydrogen gas and sodium hydroxide. Okay, this is your first reaction of Kolbe's electrolysis, that preparation of alkane. Similarly, we can take that if you take dicarboxylic, this is your monocarboxylic acid. If you take dicarboxylic acid, the example is like this: CH2, CH2, COONA, COONA. This is your sodium salt of succinic acid, sodium succinate. We can tell this is sodium succinate. Sodium succinate. This sodium succinate when undergo electrolysis, then product is your alkene. Product is alkene. Same product CO2, hydrogen gas and sodium hydroxide. Okay. If you take third examples, CH double bond CH, COONA, then COONA, same electrolysis, product will be, this is your acetylene and this is your ethene. then same product, carbon dioxide, hydrogen and sodium hydroxide. Okay, this is called sodium malate. Sodium malate. Okay, so if you see the mechanism, if you see the main theory, sodium salt of acid produce alkane or alkene or alkyne. Three types of main product are formed by electrolysis. You see the mechanism. If you see the mechanism, you take CH3COONA. We know in the electrolysis, first the electrolyte gets dissociated, produce cation and anion. First step is formation of cation and anion. Then second step, if you see the mechanism, this CH3, C double bond O minus, as it is a electrolysis reaction. So electrolysis, generally two types of reaction takes place in electrolysis. One is oxidation reaction. Second one is reduction reaction. So here what happens, this anion, carboxylate anion, moves towards, that is anode, then at anode it loses electron, then becomes CH3 C double bond O dot. This free radical is produced. This is your free radicals after loss of what? Electron. Then these free radicals, what happens again, if you repeat this one, then this free radical CH3 C double bond O dot undergo delocalization. This one undergo delocalization and forming loss of CO2, forming CH3 dot methyl alkyl. This is called alkyl, we can say alkyl free radical. These alkyl free radicals, it is when two molecule of, if you take two molecules of methyl free radical combine, produce ethane. So alkane is formed. Here one important thing is that the formation of free radicals, alkyl free radicals, these alkyl free radicals combine each other forming alkane. So generally in this case, in most of case, here that two molecules of alkyl free radicals combine. So generally even number of carbon involved in the formation of alkane. Two number of alkyl free radical combine to form alkane. So this is the main product, that is alkane. This reaction takes place at the loss of electron, so it takes place at anode. If you see cathode reaction, if you see the cathode, at cathode what happens? In cathode, your Na plus move towards cathode, convert to sodium. This is the case. But sodium in presence of water in aqueous medium produce sodium hydroxide and hydrogen gas is formed. If you see, this is the one way, or you can say Na plus is there, and as it is aqueous medium, H plus is also available. H plus gains one electron, become hydrogen, and this hydrogen atom combine to form H2 molecule. If you see the reduction potential, H plus has more reduction potential than Na plus. That's why H plus easily reduced in comparison to sodium plus. So we will get hydrogen gas. This is takes place at the cathode. At cathode, hydrogen gas is produced. At anode, this is the anode. At anode, alkane is formed. Then carbon dioxide already released. And the medium, this, if you already discussed, this Na plus will be converted to sodium hydroxide. So with increasing electrolysis, the pH value increases with increasing the electrolysis process. Within the continuous electrolysis process takes place, so result, the solution is more alkaline due to formation of more NaOH. So the medium is basic. The electrolysis of sodium salt of carboxylic acid, the medium is basic, pH is greater than 7. So this is also one important question. So this is about the mechanism, that free radical mechanism of Kolbe's electrolytic method. So let us discuss different application, different examples of electrolysis process. So if you see the application, if you take first example, if you take simple example I am taking, if you take sodium formate, and Kolbe's electrolytic method, result will be, what is the result? Here this is the hydrogen, so product will be hydrogen gas, and sodium produce hydrogen gas, and result is sodium hydroxide and carbon dioxide. So in both case, anode and cathode, this is both case, anode and also cathode, what? Hydrogen gas is formed due to electrolysis of sodium formic acid, that is sodium formate. The result is hydrogen gas, both at anode and hydrogen at cathode, because H plus produce, it is converted to hydrogen gas, and sodium also gives hydrogen gas at the cathode. So at anode and cathode, both hydrogen gas is formed. If you take second example, if you take, that is C2H5COONA, Kolbe's electrolytic method, the result will be, first result is your butane, this is your butane, because two are combined, already discussed the mechanism. Then side product is your carbon dioxide, sodium hydroxide, hydrogen gas are formed. But if you see, what are the other side products? What are the other side products are formed? As the mechanism is free radical mechanism, then what happens? These two free radicals undergo disproportionation reaction. So what happens? Loss of hydrogen takes place. From one free radical. So result is CH2 double bond CH2. Then when hydrogen will be added, this free radical, when it added to this one, then produce C2H6, that is your ethane form and ethene form. This is also byproduct. This is your byproduct. So butane, then ethane and ethene both are formed by the electrolysis of sodium ethanoate. So this is one very important examples, remember. Then if you take other examples, the example is like this. If you take CH2, 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 that is COONA, COONA. Okay, this Cole's electrolytic method, then product will be, as this is your free radicals, this is your free radical, as the reaction takes place in free radical mechanism, so this free radical combine, it become, the product will be like this, propane, cyclopropane will be formed. What are the other products? Other product, if these two free radical combine, if both combine, then it will be also cyclohexane. It will become cyclohexane, because these free radical, three free radicals combine with another free radicals, it becomes cyclohexane. Cyclohexane is also one product. Cyclohexane, and this is, you can see, is a major product, and this is your minor. Because more angular strength, so it is cyclopropane is less stable compared to cyclohexane. So this is one important application of that Kolbe's electrolysis. If you take another examples, let you take sodium salt of cyclohexanoic acid, if undergo Kolbe's electrolysis. So this is your free radicals. If you see, this is your free radical is formed. Then two free radical combine, produce this type of compound. Two cyclohexane combine. So dicyclohexane form by the combination of two free radicals. Okay, this is also one product. Then side product is always your carbon dioxide, hydrogen and sodium hydroxide. What are the other examples? If you take CH2, COONA, succinic acid, sodium salt of succinic acid, if you take Kolbe's electrolytic method, then what are the different products? First product is alkene. Because this is your free radical, this is your free radical. After the loss of electron, then it will become alkene, and other side product will be, as two free radical combine, it become, the product is like this. This product will be also formed as cyclobutane. Cyclobutane form. So this is your major product. Ethene is major, and this is your minor product. By the electrolysis of sodium succinic acid, sodium salt of succinic acid. Similarly, if you take another example, that Kolbe's electrolysis, the product will be, first product, that this is your free radical, this is your free radical is formed. So these two free radical combine, it become cyclohexene. What are the other side product? If you check, these two free radical combine to form another fuse ring form, but this is your minor product due to more angular strain. This is the major product. How it is produced? Because these two radical when combined to form this type of fuse ring, but when these two radical forms double bond, and this becomes cyclohexane. So like this, another product we can take. Another examples, if it will be like this type of salt by Kolbe's electrolytic method, it becomes, you see, this is your free radical, this is your free radical is produced after electrolysis. Then these two free radicals in both carbon forming delocalization, forming benzene. It becomes benzene product. The product will be benzene. Okay. Then like this, another example you can take. If you take malic acid, salt of malic acid, if you take, what are the side product by Kolbe's electrolytic method? First product is already you discussed. This is your acetylene, because this is your free radical, this is your free radical. There's two free radical forming a pi bond, that is acetylene. Then what are the side product? Side product is like this. This type of product will be also formed due to combination of two free radical, because already we have discussed the free radical produced can combine with each other forming another product. So this is the one also, but this is your minor product, this is your major product. Minor major product also form. This is sodium malate. This is your cis form. This is a cis form of sodium malic acid. Then what are the other examples? If you take other example like this, if you take this compound, unsaturated cyclic compound, if you take, and Kolbe's electrolytic method if you do, first product will be just, this is a free radical, this is free radical, just interact, the ring will be fused like this, these two ring will be fused through this bond. So this is one product, this is your one product plus, and these two free radical if you combine, then form another extra pi bond like this. This is also produced, but it is unstable. That is minor product, but this is your major product. Okay, because three bonds, this is a linear structure, but this angular strain is more, it cannot exist. This is a linear form and this bond cannot be exist, that's why it is not possible, the bond will break, that's why it is not the major product, it will be the minor product. Okay, similarly, what are the other examples? If you take, let us take this compound, sodium salt of dicarboxylic acid, sodium salt, when undergo Kolbe's electrolysis, if you see, one product is like this, already discussed this thing. This is called benzene product. This benzene product, it may combine and forming biphenyl compound. This compound also possible. This is called biphenyline. 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 This is the biphenyline compound and this is benzene. Both are the product, side product we can say. This is one example. This is possible only the formation of free radicals. These free radical when combined forming extra pi bond, this is your benzene. But when the through these two free radicals, when combine each other forming this biphenyl product. Okay. Then take another example. So you have to practice. Similar product will be formed. It depends upon the nature of free radical is formed. This is one examples of one sodium salt of alicyclic compound. Then when it undergo Kolbe electrolysis, here if you see this is your free radical, this is your free radical. So both free radical forming a bond. This type of product bicyclo compound is formed. Bicyclo compound will be formed as a product. Then another examples, if you take acetic sodium salt of acetic acid and sodium salt of propanoic acid, if you take both mixture, then what happens? You will get here, if both combine, then produce this product also produce as a propane, one product, plus both combine then produce ethane and also butane. These are the side products. So if you take a mixture of carboxylic acid, different carboxylic acid if you take, the result will be depending upon the formula of carboxylic acid taken. Here is methyl, so ethane is formed. Methyl means ethane will be formed, and ethyl means butane will form, and both combined produce propane. But here one thing, we should avoid to take a mixture of carboxylic acid because it will be very difficult to separate this homologous group, propane, ethane and butane. It will be difficult to separate because they are homologous. Homologous compound cannot be easily separated because very low difference of their molecular mass. So we should avoid it. Another important thing is we can't prepare which one? Methane. This is very important. By Kolbe electrolysis method, we cannot prepare methane, but other alkane, alkene and alkyne we can prepare. Other fused product, cyclic fused product also we prepare as a byproduct. But methane cannot be prepared by Kolbe electrolysis method because for the methane preparation, as the methyl free radical will be formed, these two methyl free radical combined produce ethane. So the static compound will be ethane. It cannot be methane. So remember, this methane cannot be prepared by Kolbe electrolysis method. So another example, let us take very important example, that CS3, this compound if you take, this is one dicarboxylic acid. If undergo Kolbe electrolysis, what are the possible product? You see, this is your free radical, this is a free radical. If you combine, the product will be like this. One side product is like this. This is one product because combination of this one forming one product, but it is minor product because it is unstable due to cyclopropane derivative which is unstable. This is one product, minor, unstable. This is also unstable. What are the other product? Here what happens, if you see the mechanism, here this free radical is formed methyl and this free radical is formed. This is your free radical is formed. This is your CS2. You can take this is CS2. Actually, this is your CS2 free radical. This two CS2 free radical. This is your primary. Then rearrangement takes place. It will become tertiary. How? CS3. Then here this methyl shifted to this, so it become CS2 dot, then this free radical remain, then CS2 CS3. This free radical is formed. This is tertiary free radical. We have taken primary due to rearrangement convert to tertiary free radical. This tertiary free radicals is formed. This free radical combined forming pi bond. So result will be CS3 C double bond CS2, then CS2 CS3. This is the major product. So like this, whenever any question course electrolysis method will be given or any example will be given, you see free radical, as it is a free radical mechanism, the free radical is produced, you see the stability of free radical. If the rearrangement is possible, so convert primary to secondary to tertiary. We can convert. Here primary taken, primary is converted to tertiary. So the product is major product, this one. So you have to see like this. The nature of product depends upon the stability of the compound. If cyclic compound is produced, generally it is less stable in compared to open chain compound. That's why we have to take the major product as a open chain compound, aliphatic compound instead of cyclic compound. So these are some very important examples of Kolbe's electrolysis method. You practice. Let us take one homework for you. The homework is like this. You have to give this answer in the comment box. I hope you will send your question by getting this video. When the video will be uploaded, you will get notification. After getting notification, please you solve this problem and send your answer in the comment box. If you have not subscribed my channel, please subscribe it and share this video to your friends and relatives so that others will be benefited, and those are preparing for the different competitive examination, they will be also benefited. If you like this video, please share it and subscribe it. Then my question is homework for you, because every class we should take some homework for your practice. The question is like this: what will be the product of this salt by Kolbe's electrolytic method? This is the question for you. So practice it. This is a question for you. You solve this problem. What are just I am giving some hints. It will be rearranged product. So you have to think. So what will be the correct answer? You send the answer in the comment box. I hope you understood these lessons. This lesson that the Kolbe's electrolysis method. I hope you will have better knowledge by watching this video. I hope you will be benefited more for your future examination. Okay, thank you everybody.